Good morning. Welcome you all to this session on mechanical measurements and metrology, video presentations, video series lecture number 3 today. I will be joined by my colleagues, Prof.SVC and Dr. Nikhil Rangaswamy, NR, who we call him as. So we have the plan for today as a quick review with video presentations of what was being done yesterday, and also we have some videos for you regarding angle gauges. We'll go ahead with a discussion on angle gauges. Would also like to solve one or two problems connected with angle gauges and slip gauge building. First of all, a quick review of previous yesterday discussion. Yesterday we did a discussion regarding sine bar measurement, then sine center, what are the limitations, materials. We also discussed about the surface properties, then the IT grade requirements of angle surface IT grade requirement for sine bar, which is around, as Professor Chitnis was mentioning, it is around IT04, never ever beyond IT05 or 6. Please let us understand, IT04 and anything less than that is grade, is gauge grade, 00, 1, 2, 3, 4. The normal machining grades that we have are IT7, IT8. The lathe can go up to a good quality CNC lathe can give us to IT7 or IT8. Drilling would give us around IT9, IT10. This is the range, and the roughest range or the maximum tolerance that we can grade in case of IT16 with respect to casting. So in our view, we should know, if someone asks in examination, supposing what is IT grade for this stick that I have in my hand, it looks like a telescopic stick that we have. So I should know by feel this, how much could it be the IT grade. Here I can say this should be around IT10 or IT7 or IT8. This is super fine finish, but still I can say roughly I should know. And if I hold this, this is nothing less than IT16. So this is the way we should know the range of IT grades. And with respect to sine bar, the IT grade is, the surface is maintained at IT4. And we also discussed about the relief holes. We discussed about the professor was discussing about axis, parallelism, what are the specifications needed. All this was discussed. Today's class, we will just quickly go through some few videos that have been downloaded for your purpose. Yesterday we have seen bevel protractor was shown, sine center was shown. This bevel protractor 3D animation was shown. Let's have a look regarding angle gauge first, and then we will have discussion about angle gauge. Please go through this video, how the angle gauges are being used, how to use the angle gauges, angle of crossword part, let's view it once more. Specialized angle measurement, accuracy to the tune of plus or minus 0.5 degrees. Please note again here, just like in our previous case, vernier bevel protractor, this is also 0.5 degrees. maximum interior angle that can be measured using this butt angle joint around 65 degrees, interior angle. T-joint, minimum interior angle should be 25, that can be measured. So these are all the limitations of angle gauges. Crossword part, maximum interior angle 110 degrees, minimum interior angle 70 degrees. We will have one more angle gauge video. Let's have a look.
Angles are you using? And I go, well, I'm using 40 to 45 degrees on my spindle gouge and things like that. And one time I was getting ready to go do a demonstration, so I thought I'd just measure them. Well, I couldn't find a good gauge to measure them. I finally hacked one together, and the angle was like 27 degrees on my spindle gouge. It's like, oh my gosh, what happened? What happens? Bevel creep. Because these things are all movable, no matter what you do. And no matter how perfect you are putting stuff up, even if you're just at half a degree off, you're slowly going to change the angle on your bevel. In other words, this angle is going to start either going in or out like that. So I looked all over trying to find an angle gauge where I could at least verify that the $900 or $1,000 I spent on my sharpening system, I'm getting the angle I needed. Couldn't find it. So that's when I decided, okay, well, I'm going to make my own. And that's where I came up with the Woodturners angle gauge. And this has 35, 40, 45, 55, 60, 75, 15, and then 25, 35, and 45. This is spindle and roughing, spindle and roughing, spindle and roughing. This is bowl gouge, and this is for scraper and negative rake. And then right here, these are for skews and for parting tools. And the way it works is, I got really tired of having to take my tool and stick it into a piece of metal. So what I do with this is you lay it on top and you just bring it up and you see the edge. There's no light showing through that edge. I know I'm at a perfect 45. So now I can guarantee that everything I do on my grinder is going to match with where I want to be. And the reason I put so many angles on there is because it's different strokes for different folks. You might not want to have yours at a 55. See, that's not a 55. You might want yours at a 60. It's all up to choice. You can also come up here with a bowl gouge and make it into a 75, and you can see the gap there. Until you get rid of that gap, then you have a 75. But that's how I do my scraper. I have 75 here, and then the relief grind up here, which is so tricky for everybody, I have it right there so you can see it's 15 degrees. And the neat thing is then you can take your parting tools and stick them up in there, and your skew chisels and stick them up in there, and they don't dull the tool points. But anyway, that's the gauge I came up with, and it is available on our website, woodturningwithtim.com, if you want to buy one. Also, they're going to be available in a lot of stores pretty soon, but for right now, you can find them only on our website. But to me, if you have a dull tool, you have a dangerous tool. You have to have a sharp tool to turn well, but you also have to have a tool that you can repeat the grind on consistently, so when you approach the work, nothing's changing and it's always the same. I had a problem over the years. People would always say, what angles are you using? And I go, well, I'm using 40 to 45 degrees on my spindle gouge and things like that. And
So now I hand over the mic to Dr. Nikhil. So he will be conducting the session on angle gauges and beyond, further with regard to numericals. Thank you.
Okay, hello students. So today the topic is angle gauges. So what do you mean by an angle gauge? Just like in linear measurements we use slip gauges, we also have a similar kind of setup for measuring the angles. So over here you can see over here it is the angle gauges of different angles are encased in a wooden box just like our slip gauge set. So angle gauges are basically made of high grade wear resistant steel. It works on similar principle of slip gauges. While slip gauges can be built to give linear dimension, angle gauges can be built to give the required angle. You can see over here we have one reference surface, a flat surface, and the other surface is at a particular angle. The gauge comes in a standard set of angle blocks that can be brung together in a suitable combination to build an angle. Okay, so over here you can see the slip gauge box contains very limited number of the angle gauge box contains very limited number of angle gauges. So you might have a doubt that just like in slip gauges, we should be able to build any angle using these number of slip gauges. So let's see how these are done. Most angles can be combined in several ways. However, in order to minimize error, which gets compounded if the number of gauges used is increased. Just like in slip gauges, we are supposed to use minimum number of angle gauges to build a particular angle. It is preferable to use the least number of angle gauge blocks. The set of 16 gauges forms all the angles between 0 degree and 99 degree. So there are just 16 angle gauge blocks, and using this we can build up to from 0 degree till 99 degree a total combination of 3,56,400 combinations. Yes, in steps of 1 minute. The laboratory master grade set has an accuracy of 1/4 of a second, while the inspection grade set has an accuracy of half. The tool room grade set an accuracy of 1 second. Okay, so now you might have a doubt that how is it possible to set any given angle. So he says roughly around 3,50,000 possible combinations. In case of slip gauges, we are just adding one after the other. In the case of angle gauges, we can add as well as subtract some of the angles. So over here you can see a 16 set angle gauge has the following number of gauges. So it has 6 blocks of 1 degree, it has blocks of 1 degree, 3 degree, 5 degree, 15, 30 and 45 degree. So total number of blocks is 6. Then we have in steps of minutes, we have 5 blocks. The first block is 1 minute, 3 minute, 5 minute, 20 and 30 minutes. Similarly, another 5 blocks in seconds, 1 second, 3 second, 5 second, 20 and 30. You can see over here, it's easy to remember the minute and seconds. The minute and second has the same set of values, that is 1, 3, 5, 20 and 30. Similarly, in the case of degrees, we have 1, 3, 5, the common. Next we have
we will be giving them these values, or should they remain?
This is the standard value. The students are supposed to remember these 16 set.
Say I give the example using 16 gauge block to build the following set. So is it that I have to give the
standard? No, standard will not be given. Only the
students be made known about it. We will not give the sub angle values or the gauge value. We will only mention whether it is a 6 gauge set or a 11 gauge or a
16 gauge.
And if nothing is given,
Then they can choose 16.
Yes, sir. Normal angle gauge set is 16 gauge.
Yes, sir. So students, this particular values of 16 angle gauges will not be mentioned in the question papers. So as well, they will just ask, build the following angles. As simple as that. You have to remember these 16 values and set the given angle. So now, how to identify whether you are supposed to add and how to look at the angle gauges. So say for example, we have two blocks of 30 and 5 degree. So how to set 25 degree and how to set 35 degree, we'll just have a look. So over here, usually the angle gauge has a mark similar to your greater than symbol. So using this, we can find out whether we are adding the value, we are adding the angle gauge or subtracting the angle gauge. So over here, if a 5 degree angle block is used along with a 30 degree angle block, the resulting angle is 35 degree. And if the 5 degree angle block is reversed and combined with the 30 degree angle block, the resulting angle is 25 degree. So in this way, we can set any particular value between 0 to 99 degree. However, angle blocks have a special, reversing of an angle block subtracts itself from the total angle generated by combining other angle blocks. This provides a scope for creating various combinations of angle gauges in order to generate angles that are spread over a wide range by using a minimum number of gauges. So let's take an example. So we are supposed to build an angle of 42 degree, 35 minutes and 20 seconds, which is to be built using the 16 gauge set. So just we'll have a look one by one. The value is 42 degree, 35 minutes,
20 seconds.
and 20 seconds. So can you just?
Yes.
So we'll go back to the previous slide wherein we have all the 16 sets. So first thing is we are supposed to solve for 42 degree. How to build 42 degree? So over here we have 45 degree. We can subtract 3 degree. So 45 degree minus 3 degree will give you 42 degree. Next we'll move on to the minute, that is 35 minute. So just have a look, do we have a 35 minute? No. We are supposed to add 30 and 5. We have 1, 3, 5, 20 and 30. So we are supposed to add 30 plus 5, which gives us 35 minute. And finally 20 second, we directly have a 20 second angle gauge. So we can directly use the 20 second angle gauge, and you can see over here the symbol 45 degree. To the end we have this lesser than symbol, so it is to be set first. Next, observe the symbol over here for the 3 degree angle gauge. It is placed on the opposite side. That means we are subtracting this particular value with the 45 degree. So 45 minus 3 will give you 42 degree. So this is 42 degree. Next, we have 30 plus 5. So observe the symbols again. It is to your right. So 30 plus 5 will give you 35. And finally we have 20-second angle gauge. So we have the angle ready for 42 degree, 35 minutes and 20 seconds. So over here it can be noticed in this combination that except for 3 degree angle gauge, all other gauges are added. Accordingly, the 3 degree angle is reversed and brung with the other gauges as shown in figure.
Drawing also I need to draw?
Not necessary. I think this is sufficient. This is quite clear. You can just have a look.
Please have a look. The sign here, how we mark this V here 45 degrees, and this is the way, this is a reduction or this addition, subtraction. So that has to be made clear.
Yes. So in the exam, if they ask a particular numerical to set this particular value, that is 42 degree, 35 minutes and 20 seconds, the first thing that you are supposed to do is find out the degrees, so then minutes and then seconds. So these are the values. So we are using 45 and 3, 30 and 5 and 20 minute. Okay. So total number of gauges is 5 angle gauges. Okay. This is the final answer. And after this you are supposed to show this sketch wherein
They will have each numerical around 2 or 3 marks.
Yes, sir.
One mark is for the drawing and another 2 will be for
the calculation.
Normally they will have 2 or 3 problems.
Yes, sir.
One sub question they will have 3 angle gauges to be built, and the mark allocated could be 6 or 7, 6 or 8.
Depending on the number of
Yes. So they
numeric.
are expected to, one, solve the problem, another is expected to draw the sketch. Whether it is mentioned or not, it is better that they should expected that they have to do the answer.
So the next topic is angle gauges, manufacturing and calibration. So how are angle gauges manufactured? So steel blanks are cut to the required shape and machined to the nearest size and shape. Before subjecting them to finishing operation, the blanks are heat treated to impart the required hardness. The heat treatment process involves quenching and tempering, followed by stabilizing process. The gauges are then ground and lapped using a sine table. The advantage of using a sine table is that it can ensure that a precise angle is generated without needing to use a custom made jig or a fixture. The non-gauging sides of an angle gauge blocks are ground and lapped to uniform thickness. This is followed by lapping of the gauging faces. It is important to ensure that the gauging faces are perfectly square to the non-gauging sides. The gauges are then inspected using an autocollimator or interferometry techniques to ensure that they meet the accuracy requirements. The newly manufactured or in-use angle gauges are subjected to calibration to ensure accuracy. One of the popular calibration methods for angle gauges is the interferometry method, which is quite simple and accurate way of calibrating angle gauges. So this is about how angle gauges is manufactured and the calibration. So we can, so one more numerical. So again, so this is how a question might be asked. Using a set of 16 angle gauges, set the following angle: 20 degree, 40 minutes and 10 seconds. (20 degree, 40 minutes and 10 seconds. So 20 degree, first we are supposed to set the angle for 20 degree. We have 15 and 5. So whenever possible, try to add the angle gauges rather than subtraction. Is it right, sir? We have 40. So this can be done by adding again and subtracting. Wait just a minute, sir. To set 40 minute, it is not possible with this particular combination, that is 1 minute, 3 minute, 5 minute, 20 minute and 30 minute. How to go about this? We can take 1 degree. 1 degree minus, what is equivalent of 1 degree? It is 60 minute. 60 minus 20 minute will give you 40. So over here you can.
This is 1 degree, it is not minute. So I have specifically mentioned 1 degree is equal to 60 minutes, and 60 minus 20 minutes, that gives rise to 40 minutes. So eventually you are writing 2 pieces here.
And finally we have 10 seconds. So 10 seconds is 30 minus 20. Giving rise to 10 seconds. So basically we have 2 numbers in each cases. So total number of angle gauges used is 6 for this particular combination of 20 degree, 40 minutes and 10 seconds. And Professor Chitnis has a few tips to be added to this topic.
See, in spite of a large number of combinations, still there are certain angles which cannot be built by any combination. And as a matter of fact, some angle gauges manufacturers, they specify those angles which cannot be easily built by the given set. And this becomes a very important input for design engineers. Ultimately, we build the angle to obtain the bevel surface on a product, and the product is designed by a design engineer. And in industry, there is one simple unwritten rule: what you design should be manufactured, and what you manufacture should be previously designed. If the design cannot be manufactured, then it is a failure of the design. So normally the design engineer keeps the list of angles which cannot be built, and he avoids those angles to be specified. That is very important. See, a design engineer cannot be just going to the force analysis. He must know everything about manufacturing, inspection, other things, because while designing a product, he has to take into account whether it can be machined, whether it can be set at a particular angle, whether after that, whether it can be inspected or something like that. And if it cannot be inspected, it is a design failure. That's why there is a list of angles which cannot be built easily, and that has to be taken into care. But otherwise, 99% of the time, any angle can be built. This is my input.
Thank you, sir. So over here you can see this is these are the angle gauges that we have used for setting this particular angle. minus. So over here you can see, yes sir, that is add.
Please check the sign here. These are additions, 15 plus 5, 20. Then I want to build 40 seconds, for which I'm adding 1 degree and subtracting 20 minutes. Please note this. This is the sign I have used. This is subtraction sign. This is the addition sign. Then up till this point is over. I want to build now the 10 seconds, for which I'm adding 30 seconds and reducing 20 seconds. So please note the signs. This is addition, this is subtraction, this is addition. So effectively, from this point to this point, it is 20 degrees, 40 minutes and 10 seconds. 20 degrees, 40 minutes and 10 seconds. A quick review. 15 plus 5, 15 plus 5, this is addition. Next, 1 degree minus 20 minutes, 1 degree is equivalent to 60 minutes. 60 minus 20 is 40 minutes. And this 40 minutes is built using 1 degree addition and 20 degree minus subtraction. Next, last 10 seconds, which is built by using 30 addition and 20 seconds subtraction. So this is, you can see here, 30 seconds addition and 20 seconds subtraction. Please mention all these things in your drawing. Effectively what you get here is 20 degrees, 40 minutes and 10 seconds.
So with this, you can go through any textbooks to find some more numericals regarding setting of angle gauges. So with this we'll be completing angular measurements. And one small discussion at the end. So we are using, sir. Okay. Thank you. We have a small, again a small interesting topic with regards to angular measurement, angle gauges.
See, this inspection, measurement and other things is largely developed in the European countries. So the first set of angle gauges was manufactured in European countries. But now there are two standards. One is American standard and another one is European standard. The one which was presented here is American standard. Yes. One which was presented is American standard. The European standard goes like this. It is like degrees 1, 3, 9, 27, 41. Again I repeat, degrees 1, 3, 9, 27, 41. There is 5 sets. Then 3, 9, 27, 41. That is minutes. Then seconds 3, 18, 30 and 45. So there are 4 plus 4, 8, 13 degrees. 13 angle gauges. One more interesting topic is, you may ask me one question, can I build about an angle of 120 degrees? Can I build an angle of 120 degrees? Yes, there is a, as I am talking from commercial point of view, not academic point of view. In commercial point of view, the angle gauge set is available with another additional block of 90 degrees. But it will not be a standard component. You will have to purchase as an additional component. Then what you have to do is, if it is 120, 120 minus 90 is 30. So on 90 degree block, you will have to make the 30 degree. It will give you 120 degree. But what I am saying is, it is an additional accessory. It is not a standard part of angle gauge set. So this is for your information, and it is more to do with practical things than theoretical here. But normally we in academics, we always look at the angles less than 90 degrees. So if you want to prepare for examination, look for the angle less than 90 degrees and not more than 90 degrees.
90 degrees on the scale.
But it is available accessible.
Yes, sir. So, an interesting topic suggested by Professor Chitnis. Say, for example, we have a sine bar, and we have an interesting case wherein we are supposed to set the height to 21.3782. This is an example. The length of sine bar being 200 mm. So, as you all know that we are supposed to use slip gauges to set this particular height of 21.3782. And as you are all aware that setting 21.3782 mm using a slip gauge is not possible. Either you can set it to 21.3780 or 21.3785 millimeter. So in such cases, practically they are going to round it off to the nearest value, say 21.378. So in this case, you can just observe that theta will be equal to sine inverse h by L, that is 21.3782. Switch off. By L, that is 200. So we'll be ending up with some particular value. Okay. So for this, similarly, this is theoretical, theta theoretical, let's say, but practically we are able to set it only to 21.378. So in this case, theta will be obviously slightly different than the theoretical theta. So regarding this, I would like to ask Professor Chitnis again to throw some light on this particular discussion.
Yeah. Thank you, Nikhil. It is like this. I would like to say theta theoretical equal to sine inverse of 21.3782 divided by 200. This is the exact value of the theta. But because we don't get this 2, what I am saying is theta practical equal to sine inverse of 21.378 divided by 200. Definitely there will be an error. What I am saying is theta theoretical minus theta practical equal to error. Now this error, nobody has contributed to this. Sine bar is perfect, our surface plate is perfect, we have everything at the place, but only because of non-availability of the slip gauge, there is an error. Now there are two, industrially looking at, there are 2 points. If I can sustain this error, then there is no problem. But if I cannot, then what I have to do is, I have to build 27.378 plus. In industry, there are some minute micro shims are available. Then you have to add micro shims. And then set the value to correct. So it again depends on practical thing. If I can sustain that error may be in terms of fraction of a second, then it is okay. But if you still want correct, say for example, I want to set the angle gauge here. I cannot sacrifice even in terms of say, then you will have to use the micro shims and build that angle and then write. So what I am saying is, sine bar may be perfect, our working surface may be perfect, everything may be perfect, but still there is an error. Okay, whether acceptable or not is again a practical thing. This is for your information. However, this is discussed keeping in view the industrial perspective. Thank you.
Thank you, sir. So with this, we'd like to wind up the angular measurement part. I would like to thank Professor Chitnis, sir, for giving some very important tips. And also I'd like to thank Dr. Nadkati, sir, for contributing to our classes. And from tomorrow we will be discussing limits, fits and tolerances along with design of gauges. And from the first unit we will be discussing about NPL method of converting end standards to line standards to end standards. So it is, we have completed the complete portion.
Also to go ahead with the question paper.
Yes.
That will be scheduled from, no,
We'll let you know.
once the limits, fits and tolerance numericals get over, then we can think about it.
Yes.
If time permits, we'll go ahead with the question paper discussions as well. So the plan here is for tomorrow 1 hour, we will have NLP and
NPL
method and further 1 or 2 numericals associated with that, if time permits. Then we will go ahead with limits, fits and tolerances, which would take about 3 hours of time,
Yes,
maybe 4 hours, and then if time permits, definitely we will go ahead with the question paper.
Yes.
Meanwhile also, whenever time permits, we will look at the question paper. That can be.
So that is the plan further for this particular subject. So any questions can be directly discussed directly with the faculty. Thank you.
You can post it through the Google
Classrooms.
platforms and WhatsApp. We have 4 semester 600 groups, so they can post their questions. And question paper is available online.
Yes.
The question paper is on my website. They can have a look at the question paper and see if any question is unattended by us, any one of the faculty. Let them have it and post it in our WhatsApp group.
Classroom,
We will address
Google
that
Classroom.
issue.
Yes.
All the theories, all the numericals that have been addressed, that we have looked at the question papers of past 5 or 8 or 10 years of question papers have been uploaded. Let them have a look, and if they have any questions, please, they are welcome to post their questions online through whichever the means. Okay.
Yes.
And you can also mention about the first OBE assignment which the students have missed.
Yes, and OB assignment, I think very few people have, few of them have missed the first open book assignment.
Tomorrow.
So that open book assignment will be scheduled on 21st May. That is from 10 to 2. And I request the students to submit it as early as possible through Google Classrooms, preferably Google Classrooms rather than email. Thank you. Thank you, sir.